When it's time to retire a space station or a large satellite, space agencies aim for a very specific patch of the South Pacific Ocean. It is a targeted graveyard, a place where multi-ton pieces of metal can survive a fiery re-entry and crash into the water without the slightest risk of hitting a populated area. This location is so profoundly isolated that the closest human beings to it are usually the astronauts aboard the International Space Station, passing roughly 400 kilometers overhead. Geographers call this location Point Nemo. It represents the oceanic pole of inaccessibility, the absolute farthest point you can travel from any piece of land in any direction. This animated diagram shows the geometry behind a pole of inaccessibility. You draw an expanding circle in a given space, letting it grow until its edges hit 3 distinct coastlines. The exact center becomes the perfectly locked pole. On a flat 2-dimensional map, this is simple 5th-grade geometry. But trying to apply that pristine math to the physical surface of the real world has led to decades of dangerous historical errors. The quest to pinpoint these poles reveals the absolute limits of how we measure our world. In 1958, a Soviet expedition drove thousands of kilometers into the brutal interior of Antarctica. They built a remote research base at the exact coordinates they had calculated to be the continent's center. Decades earlier, up in the Arctic, early explorers spent years risking starvation and frostbite as they tried to reach a set of static pole coordinates originally guessed back in 1927. Modern global positioning systems eventually proved that both groups of legendary explorers were freezing themselves to reach the wrong locations entirely. The math itself wasn't necessarily wrong. The problem was geographical. To find the exact center of a landmass, you first have to define exactly where its outer edge begins. Look at the sheer wall of glacial ice on the Antarctic coast. Surveyors have to decide whether the true edge of the continent is the solid rock grinding along the ocean floor, or the edge of these massive floating ice shelves that extend miles out over the open water. If geographers cannot agree on where the landmass actually ends, locating its true center remains a mathematical impossibility. During the 2000s, researchers threw out their old paper maps. They began feeding high-resolution satellite coastline data into supercomputers to settle the debate. This 3D wireframe mesh illustrates a computational method called B9 hill climbing. Instead of tracing 2D circles, the algorithm works in 3D spatial geometry. It drops thousands of points onto a terrain model, grouping and filtering them to isolate the most remote inner point. When applied to the Arctic, the newly calculated pole shifted over 200 kilometers from the spot explorers had targeted for nearly a century. The Eurasian pole experienced a similar massive jump. That shift depended entirely on a single technicality, whether the computer classified the Gulf of Obe as an ocean inlet or simply a very wide river. As our computational models achieved meter-level precision, they exposed how arbitrary our geographical definitions truly are. Treating the globe like a rigid math problem ignores an unavoidable physical reality. The Earth's surface refuses to hold still. The northern pole of inaccessibility isn't on land at all. It sits entirely on the Arctic Ocean, where the terrain is a shifting layer of fractured, floating sea ice. Because this pack ice constantly flows and drifts with the ocean currents, planting a permanent flag or constructing a monument on the exact mathematical center point is impossible. At the same time, rising global temperatures are actively eroding coastlines and melting ice shelves. The high-resolution data used to calculate these poles becomes obsolete almost as soon as it finishes processing. The Earth is a living, breathing system that actively defies our attempts to permanently pin it down with algorithms. In 2006, a group known as Team N2I set out to cross the Antarctic wasteland, using wind kites to pull themselves across the ice. By then, they had access to the updated, mathematically perfect coordinates for the southern pole, yet they deliberately plotted a course for the location the Soviets had guessed back in 1958. At the end of a grueling journey, they reached their destination. They found the old Soviet research station almost entirely swallowed by the ice pack. The only piece of the structure remaining visible above the snow was a plastic bust of Vladimir Lenin, gazing out at an expanse of isolation that was mathematically incorrect. Algorithms will continue to recalculate the true geometrical centers of these frozen landscapes. But it is our flawed human history that ultimately gives these empty spaces their meaning.